Okay, this is number 3 for chapter 8. A bead slides without friction around a loop-the-loop of figure 8.3. The bead is released from a height h equals 3.5 r. Part A, what is the bead's speed at point A? Part B, how large is the normal force on the bead if its mass is 5 grams? Okay, so first, part A. If we look at the ball, there, when it's released, there is a potential energy of gravity, because we'll define this as our zero. So there's an initial potential energy of gravity, and then when it reaches point A, it has a potential energy of gravity, we'll say final, and it also has a kinetic energy. So there is no friction, meaning that energy is conserved. So the initial potential energy of gravity equals the potential energy of gravity at point A plus the kinetic energy. So we have mgh naught equals mgh at point A plus 1/2 mv squared. So you can cancel all the m's, and then if you move all the variables to one side, you get that v equals the square root of 2g times h naught minus ha. And it tells you that h naught is 3.5. So 3.5 r. And you know that the height at A is going to be 2r because there's a circle and A is at the top of the circle. So that's 2r. So it's like that. Then you get that the velocity is the square root of 3gr. So that was part A. Part B asks for the normal force on the bead if its mass is 5 grams, and that'll be at point A. So at point A, if we look at the bead, there's the force mg down, and the normal force also points down because the surface is at the top. So, and it's going in a circle. That's a bad circle. And this is the center of the circle, kind of like that. Okay, anyways, so there's a centripetal force. So the normal force plus mg, because they're both pointing towards the center of the circle, so they're both positive, equals mv squared over r. And this is the centripetal force. So if we move the variables around, we get the normal force is mv squared over r minus mg. So if you remember from part A, v equals the square root of 3gr. So if we have mv squared over r, we're going to have 3mg r over r minus mg. So the r's cancel here, and that'll be 2mg. So that's 2 times 0.005 kilograms times 9.8 meters per second squared, and that should equal 0.098 newtons, and that is your normal force, which is what part B is asking for.